Okay, this is the first video of the series. We're going to design a unique ID generator. In distributed systems, such design is crucial to ensure that each ID is globally unique and efficiently generated. Depending on specific requirements and environments, there are various strategies for generating unique IDs. Below, we will walk through several common methods, their implementation details, advantages and disadvantages, as well as applicable scenarios. A UUID is a 128-bit identifier widely used in distributed systems. UUIDs have 5 different versions, and version 4, UUID v4, is the most common one. A UUID consists of a version number, a variant field, a random number, and possibly a timestamp, clock sequence, and a node. Note that UUID v4 relies entirely on random numbers. The advantages are: first, it does not rely on a centralized server, making it suitable for multi-node systems. Second, the 128-bit length ensures that randomly generated UUIDs are highly unlikely to collide. Third, UUID generation is purely local computation, which makes it highly efficient. While the disadvantages are: first, UUIDs are randomly generated, so they cannot be arranged in chronological order. Second, UUIDs are 128 bits long, which increases storage and transmission costs. Database autoincrement ID is a classic method for generating unique IDs, and many relational databases have built-in auto_increment functionality. Here is an example SQL statement. Whenever a new record is inserted, the database automatically generates an increment ID. The advantages are: there is no need for additional ID generation logic. Auto-increment IDs are sequential, easy to sort and manage chronologically. The database ensures the uniqueness of IDs. While the disadvantages are: when multiple machines are writing simultaneously, relying on a central database can become a performance bottleneck, and if the database becomes unavailable, the entire system's ID generation will be interrupted. Snowflake is an efficient distributed unique ID generation solution developed by Twitter. The IDs it generates are 64-bit long integers, consisting of a timestamp, data center ID, machine ID, and a sequence number. Note that the sequence number is generated within the same millisecond to prevent ID duplication. The advantages are: first, each node can independently generate IDs without central coordination. Second, IDs are generated locally on each node, with no need for network requests. Third, IDs are based on timestamps, so they possess a certain level of ordering. The disadvantages are: if the machine's clock is rolled back, it may cause ID conflicts. Redis is a high-performance in-memory database, and its INCR command can be used to generate incrementing unique IDs. Since Redis is single-threaded, each INCR operation is atomic, so there is no need to worry about concurrency issues. The advantages are: Redis operations are very fast, making it particularly suitable for high concurrency scenarios, and there's no need for complex generation logic. While the disadvantages are: all nodes depend on the same Redis instance. If Redis becomes unavailable, ID generation will be interrupted, and it may still become a bottleneck. Segment mode is an optimization strategy for generating distributed unique IDs. The main idea is to allocate a range of continuous IDs to each service node by a central server. Each node retrieves a continuous range of ID numbers. When the node needs to generate an ID, it takes a value from the allocated range. Once the range is exhausted, the node requests a new range. The advantages are: first, the central service is only responsible for allocating ranges, minimizing frequent network interactions, and second, the generated IDs are continuous, providing good ordering. Third, service nodes generate IDs locally, resulting in almost no delay. While the disadvantages are: additional logic is required to manage the allocation and usage of ID ranges, and if the central service becomes unavailable, new ranges cannot be allocated, leading to interruptions in ID generation. Thanks for watching. For more information, please visit bowsie8.com.